Hi guys, good evening. Can you hear me? Hello.
Yes, sir.
Can you
Hi,
hear
good evening, sir. Yes, sir. Yes, sir.
Hi, sir. Good evening.
Yeah, we'll start session. Yeah, sorry for delay. Some delay, little bit delay. Yes, we'll start.
No issues, sir.
Yes, last class. So last class about yes. So last class was basics started. Last class. Yes. Introduction to software, like system software, application software discussed. Next about OS discussed. About OS discussed. Next front end back end discussed. Language package discussed. Next low level, high level languages. So low level language, high level language. Next generation of computers. Yes, all the basics. The basics discussed. Basics discussed. Yes. Yes. Today topic about interpreter and compiler. Just a minute. Yes, I'm taking some water. Just a minute. Yeah. So last class about interpreter and compiler. Interpreter and compiler. Yeah. So let us start session. Today topic about interpreter and compiler. Yes, about interpreter and compiler. See, previous class about low level language, high level language discussed. See, high level language to binary code. High level languages like C, C++, Java, Python, HTML. So these are high level languages. System cannot understand these languages. System cannot understand this programming. C programming or Python, Java. System cannot understand that high level language. For example, C program. For example, C program. C program. Suppose this is some C program. Yes, looking like English language, right? But system cannot understand. System cannot understand this English language. C program. System cannot understand. Suppose let us take some Java code. Suppose this is some Java program. System cannot understand. So this is English language. System cannot understand. Now this language, high level language, it's high level language. This high level language has to convert into binary codes. High level language to binary codes. High level language to binary code. For this, yes, interpreter or compiler. Okay, interpreter or compiler. Interpreter or compiler converts from high level language to binary codes. Interpreter or compiler. Interpreter or compiler converts from high level language to binary codes. Okay, so what is interpreter? What is compiler? Our topic is about interpreter and compilers. Yes, today topic is about interpreter and compiler. Okay, interpreter and compiler. Okay, today topic is about interpreter and compiler. Okay, so interpreter and compiler. Yes, about this. Yes, first of all, let us see about interpreter. First of all, let us see about interpreter. Yes, for interpreter, yes, I am taking Python example. Python is the interpreter based language. Python, yes, Python scripting. Python scripting. So what some test.view, some Python scripter. I'm taking Python script for interpreter. For interpreter, I'm taking some Python scripter. Okay. Yes. So Python scripter. How Python? Yes, Python is a interpreter based language. Python is a interpreter based language. Python is a interpreter based language. Okay. Yes, I'm taking Python for interpreter example. Python. Yes, Python script. Yes. Just I'm using some notepad. D drive. Test folder. Yes, this is here. I'm developing some Python script. How that Python script is working? How that Python script is working? Let us see. CMD command prompt. Command prompt. From this, yes. Now D drive and test folder. You should go to D drive from the test folder. Okay. So D drive D colon that will take to D drive. D colon will take to D drive. DR. Yes. See, here's a direct test directory. This directory. Okay, see, exit, repeating once again, CMD, command prompt, open a command prompt, now D colon, that will take to D drive, now D drive contents, D directory, of D drive, see, these are D drive contents, so these are D drive contents, yes, in this they say test is a directory, okay, yes, here is a folder. In GUI, test is a folder. Folder directory both are same. Folder directory both are same. Okay, folder directory both are same. See, in GUI calling as folder, it's a folder. It's a folder. Yes, in character interface calling as directory. It's a directory. Directory. Both are same. Both are same. Both are same. Both are same. Only terminology difference here. In GUI calling as folder, in character interface calling as directory. GUI graphical user interface, it's a folder. Character user interface, it's a directory. It's a directory. So folder and directory. Folder directory. So it's a directory. So test is a directory. Here test is a directory. It's a directory. Test is a directory. Now go to test. CD test. CD test change of directory. CD means change of directory. Now it's not there, nothing, empty. 0 files, no files. It's empty. It's empty. 0 files, empty. So test is empty. Yes, test. It's empty. Nothing is there. Empty. It's empty. It's empty, right? Now here I'm taking notepad. Yes, notepad. Notepad. Test.py, some Python script. Yes, I'm writing some Python script. I'm creating new file. See, very simple script. A is equal to 10. Yes, B is equal to 20. A is equal to 10. B is equal to 20. Okay, C equal to A plus B. Okay, print. Yes, addition. Print addition equal to C, displaying C value. Okay, C equal to A minus B. C equal to A minus B. Yes, print. Yes, print. The subtraction equal to C, displaying C value. Next, C equal to yes, A into B. C equal to A into B. Okay, print. Yes, next multiplication. Yes, multiplication. Yes, multiplication equal to displaying C value. Yes, very simple script here. Very simple script. A equal 10, B equal 20, C equal to A plus B. So first addition displaying C equal to A minus B, subtraction C equal to A into B, it's a multiplication. save it, save it, save and exit. Okay, now yes, now run it. Yeah, run it. Yes, dr check it. Yes, test that with the Python script. Python script now running for this Python interpreter. Python. It's a Python interpreter. Now Python interpreter, yes, working on the script. Okay. Python interpreter will run the script here. Python interpreter, yes, executing the script. Python, it's the interpreter. Python interpreter working on script here, running the script. See this, run it here. See this. Addition equal 30, subtraction equal -10. Yes, multiplication equal 200. Okay. Yes, directly running script here. Suppose if it is C and C++, first checking for all the errors. C and C++ will check for all the errors. C and C++ will check for errors. Or compiler check for errors. But here interpreter it won't check for errors. Directly running program. Interpreter directly will run the program. Interpreter, it will run the program directly. It will run the program directly. Suppose any error comes, what happens? Suppose any error is there, what happens? Let us see with errors. With error, suppose here comma missing. Comma missing. Okay. Suppose here bracket missing. Suppose here double quotation missing. Totally three errors. Totally 3 errors. Now what happens here? Total 3 errors. Now run it. Python. Yes, test that is running that here. See that. Yes, 8-line error. Actually, totally 3 errors, but only 1 error showing. It's a 3 errors. It's a 3 errors, but showing only 1 error. It's showing only 1 error. Actually, it's a 3 errors, but showing only 1 error. Showing only 1 error. Yes, let us see how this interpreter is working. How interpreter is working. Let me explain clearly how interpreter is working. See how interpreter is working. See. Here this is your Python script code. Python script. Okay, Python script. Suppose A equal to 10, first line, A is equal to 10, yes, B is equal to, yes, 20, C equal to, yes, A plus B, yes, print addition. Okay, next, C equal to A minus B, yes, print subtraction, C equal to A into B, yes, print multiplication. This is your Python script. Yes, our Python script, same this code, the Python script. 1 second. Here this code. Here same this code here. Here Python script code. Okay. Yes, how this code is working here. How this code is working. See, yes, Python interpreter. How Python interpreter is working. How interpreter is working. How interpreter is working. See, interpreter first of all checking first statement. Suppose first statement is correct. Interpreter checking first statement. Suppose first statement is correct. Yes, immediately converts that code into binary code. Yes, interpreter checking for the first statement. Syntax and everything is correct. If everything is fine, that converts into binary code like zeros ones format. Okay, after converting to binary code, this is given to processor. So processor generating finally output here. Processor will generate output finally. Okay, so interpreter checking first line. If first line is correct, immediately converts into binary code. That binary code given to processor, it will generate output finally. Okay. Now what is happening here? First line is correct, immediately converting into binary code and getting output immediately. Okay. See, next statement may be right or wrong. Interpreter never think about next coming statements. Interpreter never think about next coming statements. Next coming statement may be right or wrong. Never thinking about next coming statements. Yes, first statement is correct, immediately converts into binary code, generating outputs. Okay, next. So first statement checking, correct, completed. Next, second statement. It will check for second statement. Interpreter checking for second statement. Suppose second statement is correct, same thing. Same happens here. Same happens. Yes, converts into binary code. Given to process generating output here. Okay. So this is working of interpreter. Interpreter checks the first statement. If it is correct, yes, executing, generating output. Checking second statement. Second statement also correct, generating output. Then checking for next statement. Next statement. Suppose next statement something wrong. Something wrong, interpreter stops. Any error comes, interpreter stops. Any error comes, interpreter stops. Yes, you guys, are you understanding clearly? My voice is clear. Yes, guys, my voice is clear. Any disturbance getting? Hello. My voice clear?
Yes, sir, clear.
It's clear, right? It's very clear, right? No disturbance, nothing. Okay. Yeah. Yes, because some network changed. That's the reason I'm asking. Okay. Today network changed. That's the reason I'm asking. See, first statement checking if it is correct, then generating outputs. Second statement checking if it is correct, generating outputs. Next statement something wrong, simply stops. Any error comes, interpreter stops. See, let me show that. Here, see this. In this script, top to bottom. Here, this is first error. Next here, second error. Here, third error. Totally 3 errors are there. 3 errors. Totally 3 errors. Here it's a first error, next second error, and third one. Totally 3 mistakes. Totally 3 mistakes in this program. So when you run this program, see, run this. That Python script. Python. Yes. Test.py. So run that here. Yes. See, 8 line error, right? It is not showing all the errors, only one error. Any error comes, simply stops. That error, because of this error, stopped here. Stopped. It is not showing other errors. It shows only one error. It shows only one error. It shows only one error. Any error comes, simply stops. Any error stops. Any error stops. Okay. Any error stops. Okay. Now let us correct that mistake here. Comma missing. Here comma missing, right? Comma missing. Comma missing. Now submit again here. Again run it. Yes. Now 12th line error. Previously 8th line error. That error fixed it. Now 12th line error. 12th line error. 12th line. 12th line error. 12th line. Yes, here this is mistake. 12th line mistake. Here this also cleared. Okay. That fixed it. Now run again here. Yes, now 16th line. That means it's showing only one error. It's showing just only one error. Any error comes, simply stops. Any error comes, simply stopping. So this is showing only one error. Just showing only one error. Only one error. So next error. So this is next error. Okay. Yes. Now after correction, now run it. Let us run it. Yes. Complete it. Yeah, this is working of interpreter. See how interpreter is working. See interpreter checking line by line. First line correct, executes. Next line correct, executes. Next line something wrong, simply stops. This is about interpreter. I hope you understand, guys. Okay, line by line checking and execution. Checking if correct and execution. Checking something wrong, simply stops. Simply stops. So this is about interpreter. Next, let us say about compiler. How compiler is working? About compiler. About the compiler. Yes, how compiler is working? How compiler is working? Yes, about compiler. See about compiler. Okay, for this I'm taking C program. For compiler, taking C program. Okay. Suppose some test.c. Yes. How compiler is working? Let us say about compiler. Compile suppose C program. C program. One second. Let me show C program. Suppose this is C program. One second. No, one second. Okay, one second. See here, I'm writing some C program. Hash includes stdio.h. Hash includes convert.h chapter file. Next Byte main function starting. Okay, int a is equal to 10. Same program in C language. Int b is equal to 20. Next int c declared clr scr to clear the screen. Okay, yes. So first, c is equal to a plus b. It's addition. Printf slash n. Addition is equal to ld comma c. This thing c value. Next c equal to a minus b. Printf slash n. Subtraction equal to personal d comma c. Okay, next c equal to a into b. C equal to a into b. Printf slash multiplication. Multiplication is equal to personal d comma c. This thing c value. Okay, c equal to a plus b. Addition, subtraction, next multiplication. Okay, after this finally get ch closing. So this is our C program. Okay, C program, simply C program. One second. First of all, let me save it. Save. This is some test.c program. Saved. Test.cpp. See, both are same. CPP and C both are same. C++ compiler using for C language also. CPP, C++ compiler using for C language also. See this test.cpp where this is saved. Backend C drive, EC folder, bin folder. Here it's saved test.cpp. See test. One second. See here this is saved. See 13:10 8:02 p.m. just now saved here. At this location. See this is our program. See, so this is our program. So here saved. Now this program just I'm compiling. I'm compiling this program. Compile. Compile success. No error. Now running this program. Run. Addition 30. Subtraction minus 10. Multiplication 200. Okay. See, a equal to 10. B is equal to 20. Okay. C equal to a plus b. Addition. C equal to a minus b. Subtraction here. C equal to a and b multiplication. See compiler. Compiled. No errors. Successfully complete. Now run it here. See this addition, subtraction, multiplication. Now suppose there are some mistakes. What happens here? There are some mistakes. Okay, suppose here semicolon missing. Suppose here bracket missing. Suppose here this bracket missing. Suppose here semicolon, this semicolon missing. Some missing statements. Okay, suppose here this bracket missing. Suppose here this semicolon missing. Now saved. Now compile it. Compile. See the errors. How many errors here? Totally 8 errors. Showing all the errors from top to what errors. Press any key. That error. See that first error. 10th line error. Next 12th line error. See at the bottom. Error showing 10th line error. 12th line error. All errors from top to bottom. See compiler working here. How compiler is working? How compiler working? Compiler checking for the first statement. Compiler checking for the first statement. If it is correct, yes, even correct, it won't convert into binary. No, immediate. It won't convert. Checking for next line. Next line also correct. Then checking next line. Suppose something wrong. Something wrong here. Yes, compiler says that error at some line. Compiler shows that error at some line here. Error at some line. Yes, after that, checking for next line. Next line also correct. Next line also correct. Then checking for next line. Suppose next line also correct. Then checking for next line. Next line. Suppose something wrong here. Yes, one more error. Error at some line. Next checking for next line. Next line also correct. Then checking for next line. Okay, like this, compiler checks whole program from top to bottom and shows all the errors. Compiler shows all the errors from top to bottom. See, interpreter, what's happened here? Interpreter, any error comes, stops. If any error comes, interpreter stops. Any error comes, interpreter stops. But compiler is not like that. Compiler checking whole program from top to bottom. Yes, even error comes, it goes next line also. Next line, next line, next line, next line. Compiler checks whole program from top to bottom. Complete whole code from top to bottom and shows all the errors. Compiler shows all the errors. Checking all the statements shows all the errors here. See that here is showing all the errors, right? All errors. All errors. Compile. See that 8 errors. 8 errors from top to bottom. See. 10th line error. See at the bottom you can see 10th line error. Next 12th line error. 14th line error. 16th line error. Yes, next 20th line error. Like this, top to bottom. Yes, compiler shows all the errors from top to bottom. Shows all the errors from top to bottom. Now let us correct mistakes here. Semicolon missing. Okay, suppose here this bracket missing. Okay, yes, next here semicolon missing. Okay, yes, here semicolon missing. Okay, now saved. Yes, overwriting. Now compile. Yes, still 2 more errors. Still 2 more errors. Yes, here error. So here bracket missing. Here bracket missing. Yes, save it. Saved. Yes, saved here. Now compile again. Yes, one more error. Yes, this line. Yes, here bracket missing. Okay. Yes, save it. Yes, saved. Now compile it. Yes, no success. Success. Compile successfully completed. Yes, if no errors, what happens? What is next step? So compile checks for all the errors from top to bottom and showing all the errors. All the errors. Suppose no errors. What happens here? Suppose everything is fine. Okay. Yes, after correcting errors, after correction of errors, recompilation. Recompilation. After correction, recompilation. So next time, no errors. If no errors, what happens? Yes, everything is fine. Everything is fine. No errors. If no errors, then compiler opens one more file. Compiler opens one more file. Yes, compiler checks the whole code from top to bottom. Compiler checks the whole code from top to bottom. After checking, if no errors, compiler convert this whole code into binary format. Yes, like 0s 1s format. Like 0s 1s format. That complete code converts into binary format. 0s 1s format. Converting into binary format. Just the converting to binary, that whole code converts into binary format. The complete code converts into binary format. Okay, this whole code converts into binary format and write to another file. Yeah, this file is called as exe file. Test.exe. Exe means executable file. Exe means executable file. Executable file. Test.exe file generates. Yeah, that exe file given to processor. Exe file given to processor. So processor taking the exe file, executing, generating output finally. Generating output here. See, compiler checks whole program from top to bottom. If no errors, generates one exe file. That exe file given to processor. So executing. So finally generating outputs. So all statement executing at a time and generating output here. This is what is happening here. Now let us see here also test.cpp. So backend test. Yes, 1 second. I'm deleting some files here. Not necessary for us. I'm deleting some files. See test.cpp. See, I'm compiling this file. Compiled, no error. See, compilation, compiled, success, no error, no running. So when I run this, what happens here? See backend, some file created just now, 8:11 p.m. 13:10, 8:11 p.m. Some file created. Application means exe file. Property, see that properties? Exe. The test name of the file test dot exe extension dot exe. So test dot exe file created. That exe file created. Exe file created. Okay, so it's created some exe file and executed. Okay, exe file created. See, when you come to Python scripting, see the test dot page, the Python script running directly, direct right? That Python test dot page script running directly, no exe file creating. Yes, no executable file, no exe file created. That code running directly, the source code running directly, that code running directly. Yes, your code. Yes, your code running directly. Here, no exe file created. That code running directly here. That code running directly. Simply that code running directly. No exe file created. Yes, when come to C programming, it's a compiler based. Here, exe file created. Generating one exe file and executed. Okay, generating some exe file, that code executed. That's it here. Okay, see interpreter, line balance checking, then execution. Line balance checking, then execution. Any error comes, stops. Any error comes, stops. Any error, stops. But compile is not like that. It checks the whole code from top to bottom and shows all the errors. Yes, checking whole code from top to bottom and shows all the errors. All the errors, shows all the errors from top to bottom. If no errors, generating one exe file. That exe file executes finally. Yes, checking from top to bottom. If no errors, generating one exe file. So back and here exe file generated, right? That exe file executes. That exe file executes that here. Now tell me guys, what's the difference you observed between interpreter and compiler? See this. First page and second page. Interpreter, this page interpreter, this page compiler. What's the difference you observed? Tell me guys, what's the difference you observed here? What's the difference you observed? Compiler, interpreter. What's the difference you observed? What's the difference observed between interpreter and compiler?
Interpreter runs the program by line, whereas compiler runs the entire program.
Yeah, fine, good. Next, others.
Interpreter
Yes,
directly
yes.
executes the program.
What's the difference you observed here?
Interpreter directly outputs the
See, 1 second. 1 second. See, this page and this page. What's the difference you're observing in these two pages? First page and second page. What's the difference you're observing in first page, second page? What's the difference in these two pages you're observing here? First one interpreter page, next compiler page. In explanation, what's the difference you observed here? In these two pages, what's the difference observed here? See, this is interpreter page, interpreter explanation. Is a compile explanation. What is the difference you observed here? Yes, showing that clear, the page itself showing clear.
Binary code.
Yes.
Conversion into binary code. Interpreter
Yes.
stops
Yes,
converting
even
into binary
interpret
code when there is error.
Yes, interpreter also converting to binary code. Here also binary code is there. Compiler also by both cases binary code, but some difference is there. What's the difference you observing in these two pages? What's the difference you observing between these two pages? See here one box, right? I'm seeing only one box. Two boxes, right?
Sorry, here less coding and here it is more coding. More lines of coding.
Compiler will
Okay.
compiles the whole file first, and interpreter will throw the error at the first line where it get error.
That's okay. Yes, see.
Compiler.
Here box observed, right? When come to compiler, two boxes. First box is your code. What is second box? This is what is second
Executable
box?
file.
First is exe file, right? Yes, the difference. So this is main difference. Interpreter compile main difference exe file. Compiler generates exe file. Interpreter don't have exe file. Interpreter does not generate exe file. See C program will say compiler based. That exe file generated. C program will say compiler based. That exe file generated. Exe file generated. When come to interpreter, no exe file. That does not paste. The script executed directly. Script executed directly. Script executed directly. But compiler exe file generated. Compiler that exe file generated. Exe file generated. So this is main difference here. Yes, let me explain one by one points here. Yes, interpreter versus compiler. Let us see. Point space we'll discuss. For better understanding, let us see point space. Yes, interpreter versus compiler. Interpreter versus compiler. Yes, interpreter versus compiler. Let us see that comparison here. Interpreter versus compiler. Interpreter versus compiler. That comparison. Yes, interpreter. Next compiler. Interpreter compiler. See interpreter. First difference. Yes, interpreter. It checks the code. It checks the code line by line. It line by line. Compare whole code from top to bottom. Whole codes from top to bottom. It checks whole code from top to bottom. Okay. See interpreter. It checks the code line by line checking. Compiler whole code from top to bottom. Next. Yes, output. Interpreter generates output. It generates outputs line by line. It generates output line by line. Compiler at a time output. That exe file executes at a time giving output here. At a time output. Yes, it gives output at a time. See, compile is line by line. First line checking, then giving output. Next line checking, then execution. Next line by line. But compile is not like that. One exe file generates. That exe file executes. At a time generate output. At a time generating output. At a time generates output. At a time generates output. Okay. Next. See interpreter only one error, right? Yes, it shows only one error. It shows only one error. Yes, interpreter. It shows only one error. Any error comes, interpreter stops. Means it shows only one error. Compiler. Yes, compiler. It shows all the errors from top to bottom. Okay, compiler shows all the errors from top to bottom. Yes, that shows practically. We discussed interpreter is only one error, but compile is all errors from top to bottom. Next important difference, exe file. Yes, it does not generate exe file. It does not generate exe file. Interpreter does not generate exe file. Compiler generates exe file. See interpreter. It does not generate exe file. Interpreter. It does not it does not generate exe file. Compiler, it generates exe. Interpreter does not generate no exe file. Yes, compiler generates exe file. Exe file, right? Yes, here interpreter it executes source code directly. It executes source code directly. Yes, interpreter it executes source code directly. Compiler it executes exe file. It executes exe file. Executes exe file. Okay, see interpreter. See, Python is a interpreter based language, right? See here, Python script just script executed directly. Yes. So this is your source code. Notepad. Yes, see, this is source code, right? This source code executing directly. Yes, no exe file. This code executing directly. It's a source code. That source code executing directly here. Yes, that Python script directly executing no exe file. No exe file. But C language what happens here? Yes. Yes, in C language what happens? First it will generate one exe file. So backend run it. First exe file generates and executing exe file. Now exe file. See this test.txt is 8:21 p.m. A second time just now exe file created. Exe file created executed here. Okay, so compiler generates exe file and executes. Okay, interpreter it does not generate exe file. Compiler it generates exe file. Yes, interpreter it executes source code directly. It executes source code directly, but compiler it executes exe file. Yeah, this is main difference. Okay, important difference is these 2 points. Okay, yes, next difference. So what is next difference here? So what is next difference? See the next difference. Yes. See, interpreter based languages are called scripting language. These are scripting languages. They are scripting languages. Interpreter based languages are called scripting languages. So these are called programming languages. Scripting language and programming language. Interpreter based is scripting language. Compiler based is programming language. Scripting language and programming language. Scripting and programming. Yes, scripting language examples. Scripting language examples. Python is a best example of scripting language. Python. JavaScript also scripting language. JavaScript. HTML also scripting language. PHP also scripting language. Next, Perl scripting language. Linux shell scripting language. Programming language examples. C. Yes, and C++. Next, .NET. C#. Okay. So these are scripting languages. These are programming languages. The scripting languages, programming language. So this is interpreter and compiler differences. Main differences 4 and 5 statements. 4 and 5. See, come to some conclusion. See, interpreter based language don't have exe file. Interpreter based language, yes, don't have exe file. Yes, interpreter based language don't have exe file. Yes, compiler everything is exe file. First of all, exe generates. Okay, everything is an exe file. Yes, exe generates and executing exe file here. Yes, compulsory. Always here exe file generates. Any compiler based language. Yes, compiler based language exe file. Exe file generates and executes here. Okay, interpreter based language don't have exe file. So this is simply conclusion. Interpreter based language don't have exe file. What is exe file? I will explain. About exe file, I will explain very clearly. Okay, so this is difference. Interpreter, compiler. So interpreter line by line checking. Compiler whole program. Next, interpreter it does not generate exe file. Compiler generates exe file. This is main difference. Okay, so interpreter executes source code directly, but compile exe file executes. So this is main difference. Okay, so interpreter, they are scripting languages. These are programming languages. Scripting languages Next, programming language, scripting language examples. These are programming language. Okay, fine, well and good, fine. But here, some guys are getting some doubt too. Yes, some doubt too. See, yes, this M and Rao always talking about many things, but he's not talking about Java. Okay, simply saying about C and C++ and many things, but he's not talking about Java. Okay, Java, is it interpreter based or compiler based? Okay, yes, we'll see now. Now let us start Java. Java. Yes, about Java. About Java. Java. Yes. Is it compiler based? Compiler based or interpreter based? Yes. Compiler based or interpreter based? Compiler based or interpreter based? Java. Is it compiler based or interpreter based? What is Java here? Is it compiler based or interpreter based? Okay. Java. Is it compiler based or interpreter based? Tell me, guys. What's your idea? Or
Both, sir.
both? Or both? Three options: compiler, interpreter, both are. Compiler or interpreter or both. What's your idea? Of course, I'll explain. Okay.
Both, sir.
Fine. Both. Okay. Saying that both. Yes, someone saying that compiler based. Someone saying that interpreter based. Okay. Fine. See, let me explain about Java. I will explain Java. Finally, you decide it here. First of all, I will explain. Okay, you decide it. Compiler based or interpreter based. Let me explain. Java. See, except Java in other languages, except Java in other languages, except Java in other languages, what happens here? Yes, source code converts into binary codes. Except Java in other languages, source code converts into binary code. That binary code given to processor. So processor finally generating outputs. Okay, except Java in other languages, source code converting into binary code. That binary code given to processor generating output here. Yes, in Java, what happens? Let us say about what happens here. Java, what happens here? Java, what happens? See, except Java in other language, suppose C program, source code to binary code. Source code means this is source code. This is source code, C program source code. Yeah, this is source code. This is C program source code. Okay, next. This is Python script source code. It's a source code. This is called a source code. Our program is source code. Source code to binary code. So binary format is like this. Binary format. Binary code. Source code to binary codes. Okay, in other language, what happens here? First is source code means your program. Converting to binary code means system understandable language and given to processor then executes. Source code to binary code. If it is Python, interpreter converts source code to binary codes. In C language, compiler converts the source code to binary code. C++ also compiler. Suppose HTML interpreter, JavaScript also interpreter. Either interpreter or compiler. Yes, interpreter or compiler. Some languages interpreter, some language compiler. Yes, when come to Java, what happens in Java? So first of all, source code converts into byte code. Source code converts into byte code. Next, byte code converts into binary codes. That binary code given to processor. Finally generating outputs. Okay. Now what is happening here? In Java, 2 steps. It happens in 2 steps. Other language only 1 step. source to binary code directly, but in Java 2 steps. First step is source code to byte code. Next byte code to binary code. See byte code. Byte is intermediate code. So why byte code introduced Java here? Byte code introduced to make Java as independent of platform. Yes, independent of platform. Okay, so bytecode was introduced in Java. Bytecode introduced to make Java as independent of platform. Yes, the topic we'll discuss. How Java made as independent of platform, we'll discuss next. Wait for some time. Okay, right? Yes, now here source code to bytecode. Yes, source code to bytecode. This is by the Java compiler. Java compiler converts source code to bytecode. So first step is source code to bytecode. So what is next step? Bytecode to binary codes. Bytecode to binary codes. Source code to bytecode to binary codes. Bytecode to binary codes. So this is by Java interpreter, right? A source code to bytecode by the Java compiler. Next bytecode to binary code by the Java interpreter. See, let us see Java example also. Let us see some Java program for better understanding. Let us see Java example. Suppose here sample folder, D drive sample folder. Yes, empty folder. D. One second. Exit closing. CMD command prompt opens. D drive that will take to D drive here. Yes, D here. No sample folder. Sample directory. Yes, D drive sample directory. Okay, CD sample change CLS. Here nothing empty, 0 files. Yes, here I am writing some Java program. Actually, Java using Eclipse. See, your daily class using Eclipse. Java development is Eclipse here. For understanding purpose, yes, I'm using Notepad here. Simply our topic is about compiler interpreter. For that, Eclipse is not necessary. Okay, at the command prompt, let us see. At the command prompt, see Notepad test.java. Notepad test.java. Yes, now creating new file. Yes, public class test starting ending. Okay, yes, public static byte main. Yes, string square bracket string docs. Okay, starting ending. Okay, here system dot yes out dot yes println yes hello world closing this. So this is simple Java program. Very simple Java program. Okay, this is source code. Java source code. Save and exit. Not DR check it. See test.java. Just now created 8:34 PM. Just now created. Now let me come. See test comparing. Yes, compiled. Result is dot class file generated. Dot class is a bytecode file. It's a bytecode file. See Java, see test.java. So test.java given to Java compiler, compiled, generated dot class file. Now what is happening here? See what is happening here. Test.java. It's a source code file. It's a source code. So source code file given to Java compiler, Java C Java compiler, test.java. Source code given to Java compiler, Java C. Okay, Yes, checking for errors. No errors. No errors generated dot class. Test dot class. It's byte code. Yes, dot class a byte code file. It's a byte code. It's a byte code. Byte code file generated. Okay. See here. Test.java. It's a source code. That source code file is given to Java C with Java compiler. Checking for all errors. No errors generated on dot class file. Now this dot class file. Yes. Now dot class a byte code. So that byte code file generated. Now this one you have to run it here. Java test running. Yes. Executed. See here. Java. This is Java compiler. Java C means Java C means Java compiler. Java C means Java compiler. It is Java compiler. Java C means Java compiler. Java C, it's a Java compiler. Java C, Java compiler. Now Java test. What is this Java? It's an interpreter. This is compiler. This is Java interpreter. This is compiler. This is interpreter. Compiler, interpreter. Compiler, interpreter. Compiler, interpreter. Okay. Compile interpreter. Now what happens here? This test.java given to Java compile generate dot class. Now this dot class file, see dot class file taken by Java. It's a Java interpreter. See test.java taken by Java compiler. Java C compiled generated one dot class file. Yes, the dot class file given to Java interpreter and executed. Yes, now test dot class file. This is yes given to Java interpreter. Java interpreter. A tested dot class file will be given to Java interpreter. Java interpreter. Because Java class file converting into binary codes. Converting into binary codes. So interpreter converts into binary code. After that binary code will be given to processor. Processor. So processor generates output simply generating output. Now what is happening here? Yes, in Java errors. Errors checking by the compiler, error checking by the compiler, error checking by the compiler, error checking by the compiler. Yes, if no errors, then it generates dot class file. If no errors, it generates dot class file. So in Java errors, see in Java errors checking by the compiler. Java errors checking by the compiler. Yes, if no errors generates dot class file. Generating dot class file. Okay, after generating dot class Java, the Java program dot class file. Java program dot class file. Dot class file executing. A Java program dot class file executing by the interpreter. Yes, executing by the interpreter. Yes, interpreter. Executing by the interpreter. Okay, so errors checking by the compiler, but program execution by the interpreter. This is what is happening in Java here. Okay, source code to byte code by the Java compiler, checking for all the errors. If no errors, generating dot class file. Yes, byte code file converting to binary code by the interpreter and executes here. Okay, the source code to yes byte code by the Java compiler. That byte code taken by the interpreter executes generating output here. Now what is happening in Java here? Yes, errors checking by the compiler, program execution by the interpreter. This is what is happening in Java here. Now tell me, Java, is it compiler based or interpreter based or both here? As per this explanation, yes, Java, is it compiler based or interpreter based or both here? What's the answer? Yes, come to some conclusion now. Yes. What is Java? Java depends on what? Hello guys, please respond.
Both.
You can see in chat
It is
box.
a combination of
Not only yes, it's a both. Answer is simply both. Answer is both here. Compiler as well interpreter. Both are involving. See here, first compiler involving errors by the compiler. program execution by the interpreter. Both are involving here. Both are involving. Okay. So Java depends on compiler as well interpreter. Compiler as well interpreter. Java depends on both 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 compiler as well interpreter. That's it here. So errors taken by the compiler, program execution by the interpreter. That's it. Okay. Yes. Here some question for yes. Some question. Can we create exe file in Java? Okay. Or question asking like, is there any exe file concept in Java? Any exe file concept in Java? Yes, is there an exe file concept in Java?
No.
No, sir.
Can we create exe file? Yes.
No.
See, in this process, first program develop notepad test.java. Next compile, we got the dot class file, then executed. In this total process, have we observed any exe file?
No.
No, right? Yes, no exe file after dot class is not exe file. Don't have exe file. No exe file concept in Java. Okay. It is no. Yes, it's an interview question. Definitely asking this question. It's an interview question. Answer is no. We can't create exe file. No concept of exe files in Java. See, exe file is yes. 1 second. No concept of exe file in Java here. Okay. See, there is no concept. Yes, there is no concept. There is no concept of exe file. There is no concept of exe files in Java. There is no concept of exe files in Java. Okay. Yes, in Java, everything is dot class file. Everything is a dot class file. Everything is dot class file. See, dot class is not exe file. See, dot class file. Dot class file is not an exe file. Dot class is an exe file. So then, what is exe file? See, exe file is a binary code file. Exe file is a binary code file. Exe file is a binary code file, and it's a system understandable language. System understandable language is system understandable language. What is dot class file? See, dot class file is a byte code file. It's a byte code file. Yes, it's a byte code file. It's a JVM understandable language. It's a JVM understandable language. Okay, exe file is a binary code file. System understandable means processor understandable. Dot class file is a byte code file. It's a byte code and JVM understandable. Okay, next one more difference. Exe file is a voice dependent. Exe file is a voice dependent. Yes, dot class file. Yes, dot class file is a independent. Yes, independent of platform. Independent of voice. Okay. Yes, see, Java is independent of platform means no exe file concept. See, wherever exe file concept is there, that's a voice dependent. But Java don't have exe file concept. That's the reason it's independent here. Yes, this topic tomorrow discuss. Tomorrow about about Java features. How Java made us independent platform. Okay, that time we'll discuss about exe file dot class file. What is exe file? What is dot class? The differences we'll discuss very clearly tomorrow. Okay, exe file, about exe file I'll explain very clearly. About dot class file also I'll explain very clearly. Tomorrow we'll discuss. Tomorrow topic, independent platform. See, tomorrow topic is very, very important. Even interesting also. Tomorrow we'll see wonderful session. Tomorrow definitely it will be a wonderful session. 1 second. See, you guys may be joining or not, that is secondary. Leave about it. Joining into my classes are not secondary here, but tomorrow try to attend class. No worry. Even not paid fees, no worry. Tomorrow attend class. You see the class tomorrow class. Definitely tomorrow is a wonderful class. Wonderful class. Okay, attend that. Yes, try to see that class here. Okay, no worry. Even please feed or not, attend tomorrow class. Yes, it's a wonderful class. See, maybe joining may not, that is secondary later, but don't miss tomorrow class. Okay, yes. So tomorrow topic is about independent platform features. How Java made us independent. Tomorrow discuss. See today topic interpreter versus compiler. The difference is clearly explained here. Same about Java. Java depends on both the compiler as well interpreter. Same topic explained here. Same topic as is. Everything covered in the document here. Nothing missing the documents. Yes, tomorrow starting Java features. Tomorrow Java features. Okay. Yes, after finishing independent platform, next Java setup, Java installation Eclipse. Yes, we are going to start working on Java from tomorrow. Yes, we'll be starting. Yes, installation and programming also. First, we will be discussing about independent platform. After that, Java programming. That's all for today. That's all. Any doubts? Any doubts?
No, sir.
Yes, I think everyone you understand clearly, right? Yes, my
Yes,
classes
sir.
are very clearly understanding, right? Yes,
Yes, sir.
fine. Yeah. So thank you guys. Yes, tomorrow will continue for the Java features. Yes, don't miss tomorrow class. Don't miss tomorrow class. Thank you guys. See you tomorrow.